Hello everybody, this is Unit 9, Lesson 3. And the learning target is I can solve quadratic equations by factoring and using the zero product property. And let's just go straight to the do now. And we're using square roots to solve. So by now, you should be able to do this pretty easily. The objective is to solve for the variable. All right, so once you solve for the variable, I'll do number 1 with you. You could do number 2 on your own. The last step will probably always be square root both sides because you're always going to have a squared and using square roots to solve. So for number 1, 16k squared equals 121. So what do you do to solve for k or start to solve for k? You're dividing by the number that is next to the coefficient, which is 16, which is next to the variable. All right, you're dividing by 16 on both sides, and then you cancel. Now I have k squared equals 121 divided by 16. Since I do not know that, I am going to go to the calculator, do 121 divided by 16, and let's see if that comes out to be a perfect square. It does not. So we have 121 over 16, and we have 7.5625. And if I do take the square root of 7.5625, let's see what that comes out to be. 2.75. So k equals, and remember when you take the square root of both sides, you have a positive answer and a negative answer. So I'm going to put this plus, I'm going to put plus minus 2.75. See, it didn't look like it was going to amount to anything, but that's a pretty good number, all right? So k equals positive 2.75 and a negative 2.75. All right, so go ahead and try to solve number 2 and see if you can do that. Press pause now. So we have x squared minus 20 equals 0. You add 20 on both sides. You get x squared equals 20. You square root both sides because the opposite of squared is square root. And you get x equals plus or minus square root of 20. 20 is not a perfect square. So when I did take the square root of 20, I got 4.47. And then it went on forever. 4.472135. And I just rounded it off to 4.47. And it's the positive 4.47 and a negative 4.47. Same thing with this if you leave it this way. All right, so let me just do number 1 with you. It says factor each expression by grouping. We did this already, but the thing is that when you don't do something for a while, it gets confusing and you lose track of what to do. The first thing you do is to multiply A, which is 2, times C, which is 14. So in this case, it's just a lot easier when everything is positive. So you have 28. So now you have to go ahead and look at 2 numbers that multiply to 28 and that add or subtract to, I shouldn't say add or subtract, I just add to 29. And that's pretty easy because the first one that is on my list, 1 times 28, and if everything is positive, that adds to 29 and it also multiplies to 28. So I have 2c squared. I'm just going to bring that down, and then all of a sudden I'm going to bring down this positive, and I'm going to just put 1c. Instead of 29c, I'm going to put 1c plus 28c. And that is 29c. Remember, you don't change it. It's just that you're replacing that 29c with factors that add to 28. I'm sorry, that multiply to 28 and that add to 29. So now I'm just going to write down that 14 and everything is ready to go. So now I start factoring. So I factor the first two. So I have C, definitely, as a greatest common factor. And I have 2C inside the parentheses because C times 2C is 2C squared. And then C times what equals 1C? C times 1. I'm going to put a plus in the middle. And 28 and 14. Now I know a number is the greatest common factor. What number goes into both 28 and 14? Pretty easy, 14. That is it for the greatest common factor because only one of them has a C, right? So what times 14 equals 28C? Well, 2C. What times 14 equals 1? And you notice that inside the parentheses, you have the same thing, 2C plus 1. So when you factor each by grouping, you have C plus 14, the terms that are on the outside of the parentheses, and then you have the binomial inside the parentheses, and you just write that down as one of the binomials here. You write it down when you factor to find the roots, when you find the zeros, you do it this way, C plus 14 times 2C plus 1. Usually we finished right there and you factored it by grouping. But in this case, so we have C plus 14 and 2C plus 1. You put that equals 0 because you're going one step further. You're not stopping at factoring. Now you want to find the roots. That's the whole idea of factoring, all right, is to find the roots of the quadratic, right? So C plus 14, this is the way you do it. Obviously, you just put C plus 14 equals 0. And on the other side, you have 2C plus 1 equals 0. So you know what to do next. You have to just solve each equation. And usually you put it like a line in the middle, just like that. And then you go and solve. All right, obviously subtract 14 on both sides and solving each part, each equation that you created, C equals negative 14 and C equals negative a half. Those are the roots. Remember, the question didn't ask you to solve for the roots. The question asked you to express, factor each by grouping. You did that right here. This is the answer, C plus 14 times 2C plus 1. I'm just taking you one step further, obviously, that you could just split it up from there and make each equal to 0 and then solve, and then you have your roots. So basically, it's just one step added to where you are with the grouping. All right, so take a look at number 2. Go ahead, factor this expression by grouping, and then we'll come back. We'll take it that one step further to actually go ahead and find the roots of this quadratic. Go ahead, press pause now. So take a look. I have 3 times 20. That's what I'm going to do. First, I get 60. So I'm looking for two factors that multiply to 60, but that add to 32. So I just put 1 down. I automatically put 1 down. 1 times 60 multiplies to 60. I can make 61 out of it, or 59. And I'm not. This is all positives. You see all positives here? All right, so you're just adding. So 61, not what I needed. Then all of a sudden 2. 2 times what? 2 times 30 equals 60. That makes 32 if you add them. So those are my factors. I found them. I write down the 3p squared. I put down, so for 32p, I put down 2 plus 30, and that would equal 32p. 2p plus 30p, and then just copy down the 20. So when I go and factor, what can I factor out of the first two terms? Well, I could factor out a p, right? So if I factor out that p, what times p equals 3p squared? Well, 3p. And what times p equals 2p? 2. I put the addition sign down, and now I am going to factor out the second pair of terms. So I have 30p and 20p. What number goes into, what's the largest number that goes into both of those? 10. Good. It's not a 10p because the 20 does not have a p. So 10 times what equals 30p? 3p. You should get the same thing that you have here. 10 times what equals 20. And that is it. So the first binomial, I'm going to take the two factors that are outside the parenthesis. And then I'm going to take the binomial that's inside the parenthesis, and that is it. This is your answer for factoring by grouping. But now I am going to go further because I think you guys could handle it. Obviously, if we want to solve for the roots or the zeros, I am going further here. So p plus 10 equals 0. And 3p plus 2 equals 0. And there it is. I subtracted 10 from both sides. I have p plus 10, and 3p plus 2 equals 0, and I subtract 10 on both sides. I have p equals negative 10. That is one root. And then the other root is 3p plus 2 equals 0. You subtract 2 on both sides, you divide by 3, and you get p equals negative 2 over 3. That's what we're going to be doing this lesson. Just that. Okay. So, which are the roots for the equation y equals 2x squared minus x minus 10? Go ahead, use your calculator, because I would. If this was the question, I wouldn't use grouping. I wouldn't use anything else. It's set up where you could just put it into the calculator. So go ahead, try it, press pause, and get your answer now. So just take a look. I graphed it on my calculator. I inputted the 2x squared minus x minus 10. I pressed graph, and I have that. So D is out, right? Because there are definitely some roots here. So if you watched my other video on how to get the roots from on the calculator, I would watch it. You know, I would definitely, if you haven't watched it, I would definitely watch it. If you watched it, you know what's coming. So I'm going to press second function and trace. So I know that I'm looking for the zeros, and the 0 is right here. So press 2 right now. It says left bound, and that means I'm going to bring that cursor all the way up before it crosses the x-axis for the first time, and that's left bound. Right bound, I'm going to bring the cursor all the way after it crosses that x-axis, and then press enter. And then I am going to guess, and I kind of like I'll just put it right there, and I have negative 2 as one of my roots. So I know that C is my answer. Let me just look at A. A is out. 2 is my answer. It looks like 2.5 also on the other side. You see how it goes through there? But I'm just going to go check, and second function trace and 0 again. And I am going to bring it all the way over left bound, and I'm going to stop right about there. press enter. And then I'm going to go right bound, and I'm going to press enter again. And then I'm going to guess that it's right about there. And it is x equals 2.5 right there. So those are your roots, and pretty easy with the calculator. No other way I would do it if there's a question like this with multiple choice. Again, you don't have to show your work. I would just go ahead and do that. This is, I was talking about before, the zero product property. If the product of two factors is 0, then at least one of the factors must be 0. So in other words, like if you have two factors, like 5 times 0 has to equal 0. 0 times 5 has to equal 0. One of them has to be 0. So this zero product property is just like this. Split the factors. It's just the same thing. You solve for x. And just like I showed you on the prior page, I would just go ahead and split them up into two equations, both equal to 0, because one of them has to be equal to 0. X equals -5. Then you add 2 to both on both sides here for this equation to solve for x, and you get x equals 2. Those are your factors. Those are your roots. Those are your zeros, whatever you want to call them. You solved. And I'll just prove something to you right here. If I could just get this up, and you don't have to do this, but I'll mess around. If you go ahead and put x plus 5 into the calculator, and just like it is x minus 2 into the calculator, close the parenthesis, you press graph, you'll see a parabola that crosses at -5, which is right here, and crosses at 2, which is right here. So it works, all right? And this is by hand, this is algebraically, not with the calculator, and you could just roll through just like that. So anytime you're solving an equation by factoring, just make sure your equations are in standard form, right? In other words, you have to set that equation equal to 0 before you start factoring, right? And this one right here is not equal to 0. So what has to happen is basically this -6g has to go over to the other side, to the left side of the equal sign. And then you could set it equal to 0 because the right side would have nothing. So how would you get this -6g over to the left side? Well, I'm pretty sure you have it already on your page, but I'm doing this with you just to go through and just make sure that you could just pay attention and see that these steps are a little bit difficult to decipher right off the bat. So if it says solve, you have to basically get that -6g over to that left-hand side so you can get that in standard form. So this becomes 4g squared plus 6g, and yep, you bring down the equal sign, and guess what's over there on the right side? That's the 0. Now you can start factoring. So what number is the largest number, the greatest common factor, that goes into 4g squared and 6g? Yep, you guessed it. So let's take the numbers first. 2 goes into both of those, and g goes into both of those. So now we have 2g on the outside, and 2g times what equals 4g squared. So 2 times 2 equals 4, and g times g equals g squared. And that's why I'm putting 2g. And what times 2g equals 6g? 2 times 3 equals 6, and the g just comes along with it. So that's basically it, equals 0. Take a look at what happens. Now, like, you might be stuck. You're like, well, I'm supposed to make each equation equal to 0, and I don't know what to do. Well, this is one term right here. So I'm going to put 2g, and 2g, remember, it equals 0. because this has to be 0 or this has to be 0 to be equal to 0, right? So, and then I have 2g plus 3 equals 0. One of them has to be equal to 0, so it's like 5 times 0 again. 5 times 0 is 0, and then 0 times 5 is 0. One of them has to be 0 to equal 0, right? So now you have two equations. How do we solve them? Yep, we divide by 2. Now we could solve, and g equals 0. For this one, you subtract 3 on both sides. You know how to solve. And your 2g equals -3. And then you divide by 2, and you get -3 over 2, which is -1.5. G equals -1.5, -1.5. So you have G equals 0, and G equals -1.5. Listen, if this is not asking for work, I am up on the calculator immediately. Right? So if I have, by the way, all right, since I'm on my y equals screen, I cannot graph this. I cannot graph it. So you have to solve and get it to this point. That's your work, right? So if you don't show that you solved, there is no way. Like you can't just say, oh, I'm solving, and I'm doing it by the, using the calculator. No, you have to show at least this part right here, and then you're getting to that point. So you have 4g, which is x squared, plus 6x. And now you could go ahead and press graph. I don't know what happened there. And you could press graph and take a look. You have -1.5 right there, -1.5, and 0 right there. And it does match. But if it says solve the equation by factoring algebraically, guess what? You have to do it that way. All right, you could check using your calculator, but nothing else, counts. If they say solve algebraically, you must do it that way. And that's basically it. Just wanted to show you that the solutions are 0 and -3.2, 3 over 2, which is -1.5. On your own, on the bottom, these equations, solve them, and solve them algebraically. Don't do them in your calculator first. Solve them algebraically, factor them out, and then set them both equal to 0. See if you can do it without the calculator, and then put them in the calculator to check it. All right? Go ahead and try number 1. You could press pause now. Okay, so pretty easy. You have the factor them out. You have 3x. 3x times x is 3x squared, and 3x times 7 is 21x. And then you split it up. 3x equals 0, and then x plus 7 equals 0. And you go ahead and solve each for x. When you solve each for x, you get the roots. X equals 0 and x equals -7. That is it. Those are your answers. There's an or in between. Sometimes I put an and. I'm not really sure why anybody would put or, but some textbooks have or down, and some have and, some have a comma. But don't put them like coordinates, like don't put them like 0,7. That doesn't work. These are roots. These are zeros. You're solving for this. All right, x equals 0 and x equals -7. Go ahead, try number 2, but just remember, before you go ahead and try number 2, before I ask you to press pause, that 5z squared equals 5z is not in standard form. That 5z on the right-hand side of the equal sign needs to be put onto the other side, onto the left side with the 5z squared. All right. and then set equal to 0. Go ahead and do that. Press pause now. I just wanted to check in. Okay, so we subtracted the 5z on both sides. We had 5z squared minus 5z equals 0. All right, so that's standard form. Then you break it up. You factor it out. 5z, you factor 5z out because that is the greatest common factor of 5z squared and 5z. All right, so 5z comes out as the greatest common factor. 5z times, this is not a 2, that's a z. 5z times z is 5z squared, and 5z times negative 1 equals negative 5z. Right, and that all equals 0. Now you go ahead and set up your two equations. 5z outside the parentheses equals 0. Then z minus 1. And that is not a 2. I'm sorry. I'm going to put that slash there, like right there. It's like an old-fashioned z. And then you divide by 5, and you divide by 5. And hopefully you did do this. If you're following along, hopefully it works out for you. You cross out these 5s. Z equals 0. And you could put or whatever, or, and plus 1 on both sides. And what's going to happen is that z equals 1 on the other side. Just picture a parabola crossing in at the origin once and then circling back real quick and crossing back at 1. Right? So look at number 3. Remember, this is not in standard form. And just a little hint, you see this 6y squared? I mean, it's okay to bring this 18y over to the right side. You don't have to bring the 6y squared over here and make it negative. It's up to you which way you want to do it. But either way, it has to be written in standard form. So just make sure it's in standard form, n equal to 0. Go ahead and solve algebraically. Then you can check on your calculator. Go ahead. Press pause and try this problem now. Taking a look at what I did, I went opposite of what I said I was going to do. So I said, all right, let me just subtract that negative 6y squared. Let me subtract that negative 6y squared, positive 6y squared on both sides. It does become a negative 6y squared. I have to put that first because remember, I'm talking about standard form here. So negative 6y squared plus 18y equals 0. Negative 6y is the greatest common factor that factors out of that. And then you are figuring out negative 6y times y is negative 6y squared. Negative 6y times 3 is a 18y. So look, I made a mistake here. That's why you have to go over it. Negative times a positive would be a negative. And so that means that would be incorrect. And this would have to be a negative. All right? Negative times negative is positive. Just be careful. I mean, there's a lot of times that you can make a mistake here. So this is what it comes out to be, is negative 6y times y minus 3 equals 0, like we said. You divide by negative 6 on, you set up negative 6y equals 0. You divide by negative 6 on both sides, and you get y equals 0. Y minus 3 equals 0. Inside the parentheses has to equal 0 as well. You add 3 on both sides, you get y equals 3. And that's basically how you show your work algebraically to solve for the roots. So solving equations using the zero product property. What we did on the first page on the do now was take it one step further. It wasn't just factoring, all right, using grouping. It was factoring using grouping and then figuring out the roots. So it did take you for 2 questions beyond what was needed. Now, this is exactly what I was doing on that first page. You start out with a problem 2x squared plus 4x minus 30. Remember, factor by grouping. You look first for a right now you're just multiplying the a times the c, which is 2 times the negative 30, and then you get a negative 60. Then you're looking for two numbers that multiply to negative 60 and then add to 4, and you have 10 times 6 is negative 60, and 10 plus a negative 6, or 10 minus 6 equals 4. Remember, you put the 2x squared down, you just bring it down, and instead of 4x, you're going to put 10x minus 6x, and then you bring the negative 30 down, the minus 30 down. You factor out from the 2x squared plus 10x, you factor out a 2x, because that is the greatest common factor. So we have 2x times x is 2x squared, and 2x times 5 is 10x. And then in the second pair, you factor out a 6, because that is the greatest common factor between 6x and negative 30. So you factor out that 6. And you have negative 6 times x is negative 6x. Negative times positive is negative 30 equals 0. Then once you get up to this part, that's exactly what I did on the first page with you. 2x minus 6 equals 0. And x plus 5 equals 0. So that's how you would set it up. You have x plus 5, right? X plus 5, and then 2x minus 6, both equal 0. And then you can split it up like this. And what you're doing is that the factoring part is done, right? The factoring part is done, but now you're going to figure out the roots. And when you're figuring out the roots, you set up x plus 5 equals 0. And you set up also 2x plus 6 equals 0. Remember, one of them has to be equal to 0 if the whole thing is equal to 0. So one of the factors, and there's two solutions here, is x equals negative 5, or one of the roots. And then the other one is 2x equals 6, and then you divide by 2. And x equals 3. And that is it. So x equals negative 5 or x equals 3. And those are your two solutions. To solve a quadratic equation, factor it to the form demonstrated above, then use that zero product property to find the roots and solutions. You could substitute to check. All right. See if you could do all of these. Actually, go ahead and do 1, 2, and 3. We'll come back with all of the answers because these are pretty easy. Go ahead, see if you could do them. Press pause now. Okay, look at number 1. X minus 3 times x minus 7 equals 0. You split them up. X minus 3 equals 0. X minus 7 equals 0. You add 3 on both sides, you get x equals 3. And you add 7 on both sides, and you get x equals 7. So the roots are x equals 3 or x equals 7. For the second one, 7x plus 2 times 5x plus 4, you minus 2 on both sides. You get 7x equals negative 2. You divide by 7 on both sides. You get x equals negative 2 over 7. 5x plus 4 equals 0. You subtract 4 on both sides. You divide by 5 on both sides. You get 5x equals negative, you get x equals negative 4 over 5. And those are your roots. Number 3, t times t plus 1 equals 0. T equals 0, so that's one root. And then t plus 1 equals 0 also. Subtract 1 on both sides, and you get negative 1. So your roots are t equals 0 or t equals negative 1. So hopefully you did get all three of those correct. Pretty easy problems, and that's basically it. Okay, so we have a ton of practice problems here. So we have practice. Go ahead, see it, like say number one. You're going to split them into two binomials. Once you factor into two binomials, then you set them equal to 0 each, and then you could go ahead and solve for the roots. So I'm going to do like 1 or 2, maybe 3 at a time here. We'll just take it one at a time for now, and that's it. But maybe I'll do one with you. This is pretty easy. We're going to look for factors that multiply to 8, since this is, and add to 6. Since this is all addition, we could just put x and x, and then plus and plus, right? So what two numbers multiply to 8 and add to 6? Yes. 4 and 2. 4 times 2. 4 times 2 equals 8, and 4 plus 2 equals 6. So all you have to do now is x plus 4, and you're probably ahead of me. So if you are ahead of me, please go ahead to the next problem. X plus 4 equals 0, and x plus 2 equals 0, and you are ready to solve and get your roots. So you subtract 4 on both sides, on this side right here on the left side, and you get x equals -4. And on this side right here, you put an or there, you subtract 2 on both sides, and you get x equals -2. Pretty easy problem. Hopefully you do understand it. So let's go on to number 2. Number 2, remember, is not in standard form, and it is not equal to 0. So remember that 88 needs to be moved over to the left-hand side. So how would you take this 88 and push it over there? Put it over there. Inverse operations, of course. So we have subtract 88 on both sides. Remember, if you subtract 88 on both sides, there are no like terms on that left-hand side that you could combine 88 with. So what you do is you write down in standard form 2x squared minus 5x minus 88 equals, of course, 0. And you are ready to go with looking for factors. So there are no common factors that go into 2, 5, and 88. So we have to factor by grouping. So the first thing that I'm going to do is just go ahead and bring up my calculator. So I brought up my calculator. 2 times -88. And remember, it's A times C. So I get negative 176. And you know what? That is really, really difficult to go ahead and find factors of. And I am just going to tell you right now that it's going to take me a little while to find these factors. And I want you to understand that you start with 1. 1 times 88 would be 88. 176, sorry. You have to find factors that multiply to 176 and that add to a -5. So 1 times 176. This is basically how I would do it. You need a lot more room than this. So you have 176. I'm going to put down in my calculator, and I'm going to try 2. 88. So 2 times 88 is 176, and I can't make 5 out of that. That does not add to 5. 176 divided by 3. You'll get there. No good. 176 divided by 4. 44. So 4 times 44. That works. Oh, no, it doesn't. I don't know why I'd say it works. That works for multiplying, but it doesn't work for adding to -5. So I know 5 doesn't go in. So let's see, 176 divided by 6. No good. 176 divided by 7. It's a quit. Nice. Maybe I should quit. But I put 2. I'm just going to try again. 176. I pressed divide twice. That's why it's an error. No good. 176 divided by 8. You'll get there. All right. So here's 8 times 22. Can I make 5 out of that though? No. You have to keep on going. 176 divided by 9. No good. I know 10 doesn't go in. 176 divided by 11. 16. So I'm going to use this right here. So 11 times 16. Can you make a -5 out of that if you add it? You can. 11 plus a -16 would be -5. And you would multiply to a positive times a negative would be -176. So these are my factors. Do you see how long it took me to actually get to that answer? It took a long time. But eventually, if you start at 1 and use your calculator and go down to 2 and 3 and 4 and 5, you will come to factors that work. All right, so here we go. So we have 2x squared, and I'm going to write that down. I'm going to bring it down. Instead of the -5x, I am going to put a positive 11x and a -16x. And you notice that if you could check it out right now. 11x minus 16x is -5x. So, and then you just bring that -88 down, and obviously that all equals 0. All right, a lot to write here. So, greatest common factor of the first 2 terms is not 2. I don't know why I put it. But you can put x because that is a greatest common factor between 2x squared and 11x squared. So that is x. X times what equals 2x squared? X times 2x equals 2x squared. X times what equals 11x? X times 11. So out of 16 and 88, not sure. So here's my calculator again. Does 16 go into 88? No, it doesn't. So, what else goes into 16? That might go into 8. Well, that might go into 16, 16, 88. All right, so 16, 8 goes in. Parenthesis, 2x. Notice it's the same, minus 11. Negative times a positive is a negative. So that's the way you would put it. And put equals 0. So we have x minus 8 equals 0. Long problem. And 2x plus 11 equals 0. You add 8 on both sides, and then x equals positive 8. So that's basically it right there. You add 8 on both sides, and you get x equals 8 down as one of the roots, and then you subtract 11 on both sides. You get 2x equals negative 11, and you divide by 2 and you get negative 5.5, and those are the roots. That is factoring by grouping and then going ahead and figuring out the roots all by hand. If you do not have to show work and they say you don't have to factor algebraically, guess what? You put this whole thing right here, this quadratic, into your calculator and you figure out those roots. Much better than doing it by hand. Go ahead, see if you could find the factors of number 3. Press pause now. So I ran into a problem here. X squared minus 8x minus 48. I don't know factors that multiply to 48 and that add to a negative 8. So I am going to go through just like this. When you get stuck like this, 1 times 48. That's definite. Can you make an 8 out of that when you add them? No. 2 times 24. 48. Can you make an 8 out of them? Absolutely not. 3 times 16. 48. And I confirmed it in the calculator. Can you make an 8 out of that if you add them? No, you can't. So I'm going to try 48 divided by 4, and I know that works. It's 12. So 4 times 12. Can I make a negative 8 out of that? Let's see. Yes. See, you just give yourself a chance. Don't give up. And don't stare at the screen, right? Use your calculator, start at 1, and then just work through. Right? You'll get the factors. You'll get them. So we have x. We have x. And it equals 0. Right? So the factors are 4 and 12. I'm going to put them down right now. To add to a negative 8, this would have to be a negative, and this would have to be the positive. Positive 4 minus 12 equals negative 8. Positive 4 times negative 12 equals negative 48. And now I could go ahead and split up the binomials, make them both equal to 0, and solve for each. And x equals negative 4 or x equals 12. And that is it for number 3. Number 4, not in standard form, not equal to 0. Please get that negative 36 over to the left-hand side. Start factoring. Look for factors that multiply to 36 and add to negative 12. And you could solve it that way. Go ahead, try that problem, and press pause now. All right, you add 36 on both sides. You have 8x squared minus 12x plus 36 equals 0. Multiply to 36, you need factors that multiply to 36, positive 36, and add to a negative 12, and that is negative 6 times negative 6, so a negative 6 minus 6. All right, so those are your factors. That's why I put x minus 6 times x minus 6 equals 0. And then I just put them, split them up. X minus 6 equals 0, x minus 6 equals 0, and add 6 on both sides. You get x equals 6. That's it. This is a parabola that just touches at the x-axis at 6. Doesn't go through, it doesn't intersect twice. Has one solution, x equals 6. Go ahead, try number 5. Try number 5. Try number 5. Okay, so we have negative 3n. Hopefully you did get this. Negative 3n times 2n minus 5 equals 0. You take the negative 3n and make it equal to 0. Then you take the 2n minus 5, make it equal to 0. Solve each one, and you have divide by -3 on both sides of the left equation. 0 divided by -3 is 0, so n equals 0. That's one root. And then 2n minus 5 equals 0, and you add 5 on both sides, and you have 5 over 2 divided by 2, and you get 5 over 2, and that's n equals 2.5. That's basically it. Number 6, a little bit longer of a problem. Just remember, you have this is not in standard form. Remember that -5 needs to be moved over to the right, to the left-hand side, and then the whole thing should be equal to 0. Go ahead and do that. Try it. This is a factor by grouping, so it might be a little bit long, a little bit of a long problem, or might not. I don't know. So go ahead, see if you can do it. Press pause now. So nice and easy. Some of these are really difficult, but this one looks like it's a little bit easier. So you add 5 on both sides because you need to get that -5 over to the left-hand side. Needs to equal 0 for that quadratic. So you do have 3q squared plus 16q plus 5 equals 0. Then you take a times c, which is 3 times 5. Nice small number. So that's 15. So once you have 15, you're looking for two numbers that will multiply to 15 and that will add to 16 in the number in the middle. So that's easy. You just start 1 times 15. Everything is positive here, so 1 plus 15 does work. And then, so that's what I'm saying. It's a little bit easier. So I'm writing down the 3q squared. And instead of 16q, I'm going to put 1q and 15q. My eyes are like, yikes. And then plus 5. Looking at the screen this long is not easy. Okay, here we go. So we have to factor the first two terms. So I am going to say that q is the greatest common factor. So what times q equals 3q squared? 3q times q equals 3q squared. And then what times q equals 1q? Well, I'm going to put that plus 1. Right, and that is that. That's the first factoring. So we're going to factor out a 5 from the 15q and the 5. Because that is the greatest common factor. What times 5 equals 15q? 3q. And then what times 5 equals 5 plus 1. And all equal to 0. All right, so make your equations now. Q plus 5 equals 1. No, doesn't equal 1. Doesn't equal 1. It equals 0. And then 3q plus 1. That's where I got the 1 from, by the way. Equals 0. Go ahead and solve both of those. Okay, so I split them up. I solved. I subtracted 5 on both sides. Q equals -5. Or I subtracted 1 on both sides divided by 3. Q equals -1/3. And that is that. Go ahead, try number 7, press pause now. So we have m minus 7 times m plus 2. I factored out from the trinomial, factored 2 binomials. -7 times +2 is -14. -7 plus 2 is -5. And I have m minus 7 equals 0. And m plus 2 equals 0. I added 7 on the left side, on both sides. M equals 7, and then on the for the second equation, I have m plus 2 equals 0. Subtract the 2 from both sides. The two roots, zeros, m equals 7, or m equals negative 2. So number 8 is negative 5n plus 6n squared equals 4. Remember, this is not in standard form. You do have to rearrange it so it is in standard form. Go ahead, see if you could try it, and then factor by grouping. All right, so go ahead and see if you could try it. Press pause now. So take a look at what we have. We have to subtract 4 on both sides because this needs to be in standard form. It has to be equal to 0. And now we have negative 5n plus 6n squared minus 4 equals 0, right? No. We have to get this in standard form. The largest exponent goes first. So 6n squared goes first, minus 5n goes second, and then the minus 4 goes third. The whole thing is equal to 0. You realize that this has no greatest common factor. So that means that you must use factor by grouping. Right? So I'm going to put over here 6 times a negative 4. 6 times 4. And 6 times 4 is 24. So remember, and by the way, it's 6 times negative 4. So let me just put that down, and it is negative 24. So you're looking for factors that multiply to negative 24 and then add or subtract to negative 5. And I shouldn't say subtract, but just add to negative 5. So I'm going to start with 1 times 24. I'm going to worry about the negative later. Can you make a 5 out of that? No. So 2 times 12. Can you make a 5 out of that? No. 3. Does 3 go into 24? Yes, it does. It goes in 8 times. Can you make a 5 out of that? 1, 2, 3, 8. Yeah, this is an hour long, so, you know, this is what it's come to. 3 times 8 is 24, and if to get a negative 5, this would have to be, remember you have to have a negative 24 if you multiply them. So positive 3 times a negative 8 would be a negative 24. Positive 3 minus 8 would be a negative 5. Those are your factors. You got them, right? So I'm going to write down, I'm going to just copy down that 6n squared. Instead of a negative 5n, I'm going to put positive 3n. And then a minus 8n. And yeah, so that if you combine those like terms, it would equal negative 5n. And then just bring down the negative 4. So I'm going to just go ahead and factor out my greatest common factor in the first 2 terms. I have a 3n as the greatest common factor. 3n times what equals 6n squared. 3n times 2n equals 6n squared. 3n times what equals 3n. 3n times 1 equals 3n. Then I'm going to factor out a 4 from the 8n and the 4, right? So what times negative 4 equals a negative 8n, 2n. Negative 4 times 2 equals negative 8, and the n comes along with it. What times negative 4 equals negative 4? Well, it's a plus 1. And that all equals 0. Squeeze that in there. So now I'm going to separate all of the outside. I'm going to make that one equation equal to 0. And I'm going to make this an equation equal to 0. So there it is. 3n minus 4, put that in one set of parentheses, and then 2n plus 1, put that in one set of parentheses, make the whole thing equal to 0. When I do split that up, it's 3n minus 4 equals 0. Let me make that nice and small. Then I have on the other side 2n plus 1, and that also equals to 0. I have two equations. I need to solve them both. Go ahead and solve them both, and then you'll find your roots. And just like I'm doing here, I'm pretty sure this is the easy part. 2n equals negative 1. You divide by 2 on both sides, and you get, for this one here on the left side, depends on which way you solved it, it's 4 over 3. Or 2's cancel out, and you have n equals negative a half. And those are your roots, and that's 8 practice problems that we went over. If you need anything else, please rewind the video and go over it again. That's basically it. So now it is time for the exit slip. The exit slip right here has 2 problems. Go ahead, do number 1. We'll come back with the answer. Try number 1. Press pause now. So I hope that you had 2 as your answer, 0, 5. And by the way, did you see the way these are written? These have braces in them, not parentheses. If you put parentheses, they are coordinates, and they are not coordinates. As far as like this goes, when you're saying that the solution set, you're looking for the roots, and it's not a pair of coordinates. So 0, x equals 0, or x equals 5. You do it one of 2 ways. I see x squared minus 5x equals 0. I immediately grab my calculator. And the calculator, if you see it right here, if you graph that x squared minus 5x into the calculator and you press graph, you could see exactly that the 2 is your answer, with 0, which is right here. It crosses once at 0, 0, and it crosses once here at 5. The other ones, the other choices are not really close, with 0, negative 5, and just 1 at 0 and just 1 at 5. You really just have to go ahead and graph this and use your graphing calculator. But I did it on the side in red algebraically, and it's really easy algebraically too. If you factor out an x from x squared minus 5x, factor out that x equals 0, you have 1. And then x minus 5 is the parentheses, in parentheses is the binomial, because I factored out that x times x equals x squared, and x times negative 5 is 5x, negative 5x. Then I have x minus 5 equals 0. You add 5 on both sides, x equals 5. It's really fast. Either way, by hand, calculator. I would use the calculator if it is just a multiple choice question. Again, number 2, we'll do it both ways. But go ahead and use your calculator, see what you come out with, and see if it works, and see if all that jazz, whatever. I don't know. So go ahead, press pause, try that problem now. Okay, so number 2, I did it algebraically here without the calculator. I factored x squared minus 5x minus 24. I would not do it this way. If I had a calculator in my hand, I would just put this into the calculator and just graph it. But I just want to show you that it does work out either way. X minus 8 times x plus 3. You split up both equations, you split the binomials into 2 equations, make them equal 0, put them equal to 0, you add 8 on both sides, you get x equals 8, and minus 3 on both sides of the equation on the right hand side, and you get x equals -3. 1 is your answer. I did use the calculator, so I am going to show you that I just put that in to the calculator, pressed graph. All right, you really don't need to press second function trace for this one. This is -3. You could see it's -3. So that takes out it takes out choice 3 and choice 4. And if you're taking a look at number 1 and number 2, you're taking a look right here. It's 1, 2, 3, 4, 5, 6, 7, 8. So you figure 8, and you figure 8 is right here, and you're good to go with choice number 1, and that's basically it. So that's all, and hopefully you found this video very, very helpful. That's the exit slip. Question number 1 is choice 2, and question number 2 is choice 1. Remember, watch my videos on the TI-84 help. There's 2 of them so far. I posted them on Google Classroom. Just make sure you watch them. They're very, very helpful as far as finding the vertex and finding the roots of a parabola on the TI-84. All right, see you next time. Bye, everybody.